Welcome back. I'm just going to do some examples of just the introduction to kinematics. So here we go. Here's an example. A particle travels along a straight line. So a straight line because it's rectilinear motion. According to the function x of t is equal to 3t squared minus 2t plus 1, where x is in meters and t is in seconds. So we've got some function x there. Firstly, we want to find the displacement in the first 3 seconds. Okay, so remember what displacement means. Displacement means how far has it changed in position. So what we need to know is we need to know its position at time 0. That will tell us where it starts from, and then we need to find the position after 3 seconds, and the difference in those is displacement. So x of 0 is equal, so all we do is substitute 0 into here. So 0, 3t squared minus 2t, its position is 1 at time 0. Okay, and also x, its position after 3 seconds, is equal to 3 times 3 squared, so that's 27 minus 2 times 3 minus 6 plus 1 equals 21, 22. Okay, so its position, it started at 1, it finished at 22, therefore its displacement is equal to 22 minus 1 equals 21 meters. And so that's your answer. Okay, how much has it moved? That's what displacement is asking. Not the total distance travelled, just how far has it ended up from where it started. Okay. Secondly, average velocity. If you remember average velocity, I'm just trying to squeeze this in as much as I can, that's why my setting out's no good. The velocity average, remember, is equal to, it's in the first 3 seconds, so it's equal to the position after 3 seconds minus the position initially over t3 minus t0. In other words, its position after 3 seconds, so its position after 3 seconds was 22, its position at the start was 1, over, what's the time after 3 seconds? Well, it's 3 seconds, minus the time after 0 seconds, so it's 0. Okay, so that's equal to 21 over 3 equals 7. And it's in velocity, and it's average velocity, so it's meters per second, because x is measured in meters, times measured in seconds, so 7 meters per second. Okay, good. Part C, velocity after 2 seconds. Okay, so we've got our x of t. X of t is equal to 3t. I'm not going to write it, it's going to take up too much space. Okay, I'm just trying to skip. So we've got, how do we find our velocity function? Remember, velocity is going to be equal to dx on dt. Okay, so we're just going to take the derivative of this. So let's do that. The derivative of that is equal to 6t minus 2. Therefore, what we want the velocity after 2 seconds, and so that's equal to 6 times 2 minus 2, so that's equal to 10. Its velocity after 2 seconds is 10 meters per second. Okay, cool. And D is the last one. Find when the particle changes direction. Now the particle will change direction when the velocity is equal to 0. If it's chuffing along like that and it slows down and changes direction, in that instant there, the velocity is equal to 0. And if you also think of it in terms of a quadratic or turning point, the gradient will be equal to 0 at that exact point. So, so what we need to do, we want to know when Vt is equal to 0. So Vt is equal to 0 will tell us that 6t minus 2 equals 0, and so therefore the time where that is true will be 2 over 6, or 1/3 seconds. Okay, so the particle turns around after 1/3 seconds. Okay, so that's the first example. Let me go on to a second example. Here we go. So a ball is shot upwards, projected upwards, at a speed of 25 meters per second. Find a speed after 2 seconds and B, the height after 2 seconds. We'll do that. 2 seconds. And let's do C. If I can fit it in, I'll do C. Time taken to come back to Earth. Okay, so there's our question. So a ball is projected upwards at a speed of 25 meters per second. We want the speed and its height, etc., etc. So I'll try to fit it in here. We'll see how we go. Firstly, what is the acceleration? Let's just draw. I'll try to do a little diagram in here. There's Earth, and it's getting shot up at 25 meters per second in a positive direction. Okay, we'll call that the positive direction, going upwards. So positive is upwards, and what we've got gravity pushing downwards at 9.8 meters per second squared. That's the acceleration due to gravity. So let's just write that down. In fact, A of t is equal to negative 9.8 meters per second squared. So that's your acceleration. From there, we can sort of try and figure out what we're after is speed and height and those sorts of things. So to be able to find them, we need to find a velocity function and a position function, etc., etc. Okay, so let's do this. The velocity function will be the integral of a t dt, which is equal to the integral of negative 9.8 dt. If we integrate that, we get negative 9.8 t plus c. Now, can we find c? In other words, do we know the velocity at the start? Yes, we do. A ball is projected upwards at a speed of 25 meters per second. So what we have is that v is equal to 25 when t is equal to 0. Oops. Okay, so we can use that to find the value of c. So therefore, what we've got, 25 is equal to negative 9.8 times 0 plus c. Therefore, c is equal to, that's all 0, it's equal to 25. Beauty, that tells us that the velocity function is equal to negative 9.8 t plus 25. Okay, so there's our velocity function. So we're after its speed after 2 seconds. The next question wants us to find the height, so I might as well just find the position function while we're at it. Okay, so let's just find that. So x of t, its position, will be the integral of vt. We're going to integrate again to be able to find our velocity function, position function. Sorry. So that's equal to the integral of negative 9.8 t plus 25 dt. And that's equal to t goes to t squared, and then you divide by 2, so it's negative 4.9 t squared plus 25 t plus a new constant of integration d. Now, do we know its position? I think we'll assume, it hasn't said anything, but we'll assume that the ball starts at ground. Okay, so I'll do that. So we know that x is equal to 0 when t is equal to 0. Okay, so therefore we've got 0 equals 0 plus d, which tells us that d is equal to 0. Fantastic. Now we've done a bunch of work, we haven't answered any questions yet, but what we've got is we've got some important stuff. We've got our acceleration function there, negative 9.8. The velocity function is here, we know that. And lastly, let's just write it down, I haven't even written it down yet. Lastly, we've got our velocity, our position function. xt is equal to, it's over here, negative 4.9 t squared plus 25t plus 0. So that's the function there. Right. Okay, so we'll use those three to answer some questions. Okay, I'm just going to open up another window to do that question, so I can click back just in case I forget what it was. Okay, so the first question, part A, wanted to know, I've already forgotten, that's why I was going to leave this here. We want to know the speed after 2 seconds. So let's look at the velocity after 2 seconds. Vt is equal to negative 9.8t plus 25. So let's go to that. Negative 9.8t. So Vt equals negative 9.8t plus 25. So what's the velocity after 2 seconds? Well, it's equal to negative 9.8 times 2 plus 25, and that's equal to negative 9.8, so that'll be 19.6, so negative 19.6 plus 25, and that's equal to 5 plus 0.4, so 5.4 meters per second. So what's the speed? Well, the speed is just the modulus of that, because the velocity, so that's positive, so that's going upwards, and so therefore the speed at 2 seconds is equal to 5.4 meters per second. So that's part A. Okay, let's have a look at part B. Part B, what's the height after 2 seconds? So now we want to use our x function that will tell us the height. So that's negative 4.9t squared plus 25t. Okay, so let's do that. So we've got our x function was, I've already forgotten, negative 4.9t squared plus 25t. And so then its height after 2 seconds is equal to negative 4.9 times t squared, which is 4, plus 25 times 2. That's equal to 4.9, so it's 9.8 times 2, so again that's negative 19.6 plus 50, and so that's equal to 30 plus 0.4, 30.4 meters. So that's its height. After 2 seconds, it's got a height of 30.4. Cool. Let's have a look at the last part, and then we're almost done. What's the time taken to come back to Earth? Time taken to come back to Earth. Let's have a think about that. What will the position be? What do we want here? We want x of t. We want the position to be 0. Okay, so what we need to do is solve when that's equal to 0. So therefore, what we need to do is solve x of t is equal to negative 4.9t squared plus 25t when that's equal to 0. So I'll just take it out. Oh, it's going to be horrible. Should I just use a calculator? It's going to be yuck. So I'll use the calculator. So just excuse me while I get that booted up. What's it going to be? Is there an obvious solution? 0 is the obvious solution, but the other one I can't see. Oh, so I'll just have to wait for the calculator to boot up. But this will be the end of this video, so it's annoying that now I have to boot the calculator up. And now it looks like it's not working. Come on, hurry up. So we want to solve that equal to 0. So here we go. Sorry about that little interlude. So calculator, we want to solve algebra, solve, and it was negative 4.9t squared, I think it was plus 25t from memory, and we want that to be equal to 0, solving for t, and t is equal to 0, or t is equal to 5.1. We'll go with 5.1. So therefore, t is equal to 0, or 5.1. Now, we've got two answers here, but the first answer, times equals 0, that's when it started. Remember when the ball was shot upwards at the start of the question. So that's not the one we want. So therefore, it takes 5.1 seconds to return to Earth. Beauty. There we go. Hope you enjoyed. See you in the next video.